Now let's graph exponential functions that have a leading coefficient. So remember, previously we have studied vertical and horizontal movement. That is, moving the origin of my function. Now let's learn what does the leading coefficient do. And as in other functions we have studied, the leading coefficient always modifies the rise. So let's take a look at this example. In green, I have the original function, and then the transform function in red is 4 times 2 to the power of x. This means that my leading coefficient is 4 and the base is 2. Notice that I don't have any vertical or horizontal or vertical displacement. That means that my origin, the new origin for my red function, is still 0, 0. So I'm going to start moving from here, so that I know that if I run 0, I'm going to rise my leading coefficient times my base raised to my run. So this is 4 and the base is 2. 4 times 2 to the power of 0, that is 1, so 4. So I know that if I run nothing from my new origin, I'm going to rise 1, 2, 3, 4. Now if I run 1, I'm going to raise my leading coefficient times my base raised to my run, and this is 8. So if I run 1, I'm going to rise 1, 2, 3, 4, 5, 6, 7, 8. And don't ever forget to write your horizontal asymptote. In this case is y equals 0. Why? Because we do not have any vertical displacement. And that is how you know the graph of this exponential function. Another example. Here, notice that the function is minus 2 to the power of x. But remember, the base is always positive. That means that this leading coefficient, or that this function, has a minus 1 that is affecting the exponential or the base. So this can be rewritten as minus 1 times the base to the power of x, meaning that a is minus 1 and the base is 2. So let's start graphing this function. First of all, let's see that the new origin, because we do not have any horizontal or vertical displacements, this means that my new origin is 0, 0. That is the center. Now also notice that my horizontal asymptote, because I do not have a vertical displacement, my horizontal asymptote is y equals 0. And then I'm going to apply my run rise method. So I know that if I run 0, I'm going to rise my leading coefficient times my base raised to the power of 0. And this is minus 1. And if I run 1, I'm going to rise my leading coefficient times my base raised to the power of 1. And this is minus 2. So if I run 0, I'm going to rise negative 1. And if I run 1, I'm going to rise the negative 2. Notice that in this case, because my leading coefficient was negative, this means that my function is going to open downwards. Notice that is the same pattern or properties that we have studied when working with quadratic or rational functions. The leading coefficient always tells you where does the function open, if it opens upwards or downwards. So you can easily identify the domain and the range for this function. Remember that the domain for any exponential function is all real numbers. And the range is from the horizontal asymptote towards where the function opened. Notice that this function starts from, for values of y, it starts in minus infinity, it continues, and it stops in the horizontal asymptote. So the range for this function is minus infinity to 0. And that's it. Let's check an example that combines all of these behaviors. So notice that I have the function minus 3 times 2 to the power of x minus 5 minus 1. So this function has all possible behaviors. So the first thing we're going to notice is we're going to find the new origin. For that, remember that the independent term is straight up the y-coordinate of your new origin. And to find the x-coordinate, we're going to grab the argument of the function, equate it to 0, solve for x, and that gives me my new origin. Okay, so my new origin is in 5, minus 1. Also remember that the horizontal asymptote is going to pass through the new origin, meaning that the horizontal asymptote is y equals minus 1. So here's where the horizontal asymptote is going to lie. Lastly, let's identify our run-rise method. Remember, if you run 0, you're going to rise your leading coefficient. Notice that the leading coefficient is minus 3, so it's minus 3 times the base to the power of 0, and this is minus 3. So starting from my new origin, I'm going to rise 3 negatives. And if I run 1 from the new origin, I'm going to rise minus 3 times 2 to the power of 1. And this is minus 6. So if I run 1 to the right, I'm going to rise 1, 2, 3, 4, 5, 6. So this function passes through these couple of points. It gets close to the horizontal asymptotes, and then it goes to minus infinity. So the domain for this function is, as usual for any exponential function, the domain is all possible numbers. And the range is, because remember the range is associated with the y variable, this means that if I start from the bottom, that is from minus infinity, my function stops in my horizontal asymptote. So the range for this function is from minus infinity to minus 1, not included because the function is never going to touch or cross the horizontal asymptote.